Hello guys, so today we are going to discuss this problem, minimum speed to arrive on time. So the problem goes like this, that we are given a floating point number hour which represents the amount of time you have to reach to office. Okay, so we are starting from home to reach office. To commute to office, you must take n trains in sequential order. Okay, so we have to take trains at different stops, different stations. You are also given the integer distance of length n, where describe the distance of ith train ride. Okay, so it's something like let me open auto draw. It's something like we are starting from home, then we have to travel 1 kilometer in this train, right? And then there is a distance of 3 kilometers, so we have to travel 3 kilometers in this train, and then there is a distance of 2 kilometers, so we have to travel 2 kilometers in this train, and the time uh, is 6 hours, so we have to reach office within the 6 hours. Each train can only depart an integer hour, so you may need to wait between each trains. For example, the first train takes 1.5 hours, you must wait additional 0 0.5 hours. Okay, so for example, we travel, so this is one distance we travel with one train, this is another distance we travel with another train, and this is a third train. But if we complete this distance, okay, let's take up take another example and try to see how we are going to how we can analyze this problem. So we have the distance 1, 3 and 2, and we have r as 2.7. So what we'll do, we so first of all, we know that speed is equal to distance upon time, right? So the question here is that we have to find, return the minimum positive integer speed that all trains must travel for you to reach on time. So or -1 if it is not possible. So we have let's suppose this is distance 1, this is distance 3, and this is distance 2, right? And there are three trains, T1, T2 and T3. So all the three trains must travel at the same speed. That's the first prerequisite. So let's consider that the speed of the train is 1. Initially we are taking speed as 1. So our distances were what? Our distance was, distance for the first train traveled by the first train is 1. So speed, distance divided by speed is the time taken. So if we have 1 by 1, time taken is 1 hour. So another distance was 3. So distance is 3 by 1, which is equal to 3. And another the last train need to travel distance of 2. So the time taken is 2 by 1, right, which is equal to 2. So the total time taken here, if we say total time taken or time taken, is what? 1 plus 3 plus 2, which is 6. So it means what? If our train, all trains travel with speed of 1 kilometer per hour, the first train will take 1 hour, the second train will take 3 hours, and third train will take 2 hours, and total this time is 6 hours, which is greater than the time which we are allowed to reach office, that is 2.7 hours. So this is not good. So I'll just write time is equal to distance by speed. So what we'll do, since our time is big, right, if we are traveling to somewhere and if we are taking more time, so what we do is we try to walk faster, we try to drive faster. If we are walking, if we are traveling to office and we are taking longer time, so we accelerate our car, so we will accelerate. So let's take the speed as 2. So the for traveling distance 1 will take 1 by 2, which is 0.5. So another constraint given here is we have to wait for the rounded off time. So let's go back to the question. So it says each train can only depart at integer hour. So you need to wait between trains. For example, the first train takes a ride of 1.5 hours. You must wait for additional 0.5 hours before you can depart to second train. So if the first train takes 0.5 hours, that is 30 minutes, we have to wait more 30 minutes to board on our second train. So let's say it takes 1 hour, we can round it off. Then 3 by 2 will be equal to 1.5, we'll round it off to 2, and 2 by 2 is 1, so this is 1. So the total time taken is 4. Still we are taking more time, so we have to increase the speed more. So let's increase the speed to 3. So in this case it will become 1 by 3, which is equal to 0.5, so it will be 1. Then it will be 3 by 3, which is equal to 1, so it will be 1. And it will become 2 by 3, which is equal to 0.67, which is equal to, so in the last case we have to take the number itself. Okay, so let's see where it says uh, describes. For example, the first train take, you must wait additional 0.5 hours before depart on the second. All trains must travel, the test is okay. So on the last uh, uh, train we can take the integer itself, right? Because we arrived at the destination, so we need not to wait for any other train. So here the time taken is 2.67, right? But it's still smaller than 2.7, so we'll increase more one more time. So it will be 1 by 4, which will be equal to zero point 0.5, we'll round it off to 1. 3 by 4, which will be something as point decimal or something, 0.75, so we'll round it off to 1. And 2 by 4, which is equal to zero point 0.5, so we'll take it 0.5, so it will be 2.5, right? So now if we see here, we have crossed it, right? When we have crossed the R, so we'll return the previous, that is the smaller one, that is 3 is our answer. So first method, what we have done is we are doing a linear search here on the speed. So remember, we have to do a linear search on the speed. But the another efficient method is we can do a linear search, we can do a binary search on the speed. And from where to where? So it says that tests are generated such that answer will not exceed 10 raised to power 7. So answer is speed. So what we can do, we will perform a binary search. We will perform a binary search from 1 to 10 raised to power 7, because 1 is our speed, right? Initially we'll start with 1, and our speed cannot be greater than 10 raised to power 7, so we will perform this. And what will be the time complexity in this case? So the time complexity will be equal to log of, in binary search we have a log of n 10 raised to power 7, which will be very fortunately equal to 7 only. So in all the cases we'll arrive at our solution in only in 7 steps, right? So considering this, let me start ahead with the problem with this question 321. So what we'll do is we will have a binary search from 1 as our start and 10 raised to power 7, that is 10 power 7 as our end. We will see that the time taken, if time taken is, so this is the condition, if time, let me delete this all, right? If time taken, after like we'll calculate the time, if time taken is greater than the r, right, we will increase the speed. That's the important thing. And if time taken is smaller than the r, then we will decrease the speed. And whenever we'll cross the binary search, that will be the answer. So let's see how we are going to do this. So we have taken a minimum speed. This is the start of the binary search, or we can say the left of binary search, and this is the right of binary search, right? And this is our answer speed. So what we're doing here is we are getting into the binary search when minimum speed is smaller than equal to the maximum speed. We are doing the time equal to 0 every time. So the we are calculating mid of the binary search. We are calculating it divided by 2. So we are taking the floor division, which will be rounded off to the integer, because we don't want the decimal, because it cannot fit the array indexes. Then what we'll do for all the elements, that is here 1 and 3, that is distance minus 1, that is 1 and 3 except last element, we are going to calculate distance divided by mid speed. So we are, as we saw in the example, 1 divided by 1, 3 divided by 1, and so on. We are going to add in it. And for the last one, that is distance minus 1, this is the last index, we are going to divide it by mid speed, and we are going to add it something like this. So this division is division in Python, which actually returns the floating part. But when we are doing a math seal, it means that we are rounding off to the next integer. So this will also return a floating point. So if it returns 3.2, which is equal to 1.5, so we'll round off to 2 with this math seal. And if we have that calculated time is greater than the r, so we have to increase the speed, right? So in order to increase the speed, we will shift our left, that is we will shift our left, we'll make minimum speed is equal to mid plus 1. Otherwise we will reduce our speed, and we'll keep on noting our mid speed. So whenever this um, loop will cross, that is whenever the mid speed becomes greater than the max speed, in that case we will return the out. In all the cases, the time complexity will be 7 only, and the space complexity will be O1 for this algorithm. So that's it. Thanks a lot. Have a good day.